For more than half a century, we've been gliding through the skies at virtually the same pace as travelers in the 1960s. Modern aircraft have become whisper quiet, fuel efficient, and more comfortable. Yet one metric has stubbornly refused to improve: speed. That may be about to change. A small, ambitious team from Denver, Colorado Boom Supersonic is trying to rekindle the golden age of faster-than-sound travel. With their XB-1 prototype already making headlines, they're laying the groundwork for a new era of commercial supersonic flight. And yes, their first supersonic run over the Mojave Desert has already happened. Here's how we got here, what the future looks like, and why this time it might actually work. From the Wright brothers to the Concorde, and then the silence. The 20th century witnessed breathtaking leaps in aviation speed. In 1903, the Wright brothers' flyer managed 6.8 miles per hour over the sands of Kitty Hawk. By 1947, test pilot Chuck Yeager, flying the experimental Bell X-1, pushed past Mach 1, shattering the sound barrier. Then came 1976 and the arrival of the British-French Concorde, a sleek delta-wing marvel that could cruise at over Mach 2, whisking passengers from New York to London in just 3.5 hours. It was a technological jewel, but also a financial and environmental headache. By 2003, commercial supersonic services were grounded for good. The Concorde's deafening noise and sky-high fuel consumption, 4.38 gallons per 100 passenger miles, made it hard to justify. Worse, each passenger's 1-kilometer trip generated about 42 kilograms of CO2, nearly 40 times more than modern subsonic airliners like the Boeing 787 or Airbus A350. Since then, airliners have focused on sustainability and noise reduction. Modern designs burn 80% less CO2 per seat than early jets, and noise has plummeted by over 90%. Yet cruise speeds remain locked in the subsonic zone. The dream of swift, accessible supersonic travel has been sitting on the tarmac for decades. The baby boom is born. In October 2020, Boom unveiled the XB-1, nicknamed the Baby Boom, the first independently developed, privately funded supersonic demonstrator in history. Measuring 62.6 feet long with a 21-foot wingspan, it's a compact experimental cousin to the Concorde's 202-foot fuselage and 84-foot wingspan. One thing you'll notice right away is its nose, or lack of the Concorde's famous droop snoot. Instead of tilting the nose down for better runway visibility, the XB-1 relies on an advanced camera system paired with high-resolution displays and an array of sensors, giving pilots crystal-clear visuals without sacrificing aerodynamics. The airframe blends lightweight composites, stainless steel, and titanium, with the engine section using 90% titanium for heat resistance. Boom sourced high-temperature materials from Dutch composites manufacturer 10Kate Advanced Composites, a supplier trusted by SpaceX, ensuring the XB-1 could withstand the punishing thermal loads of supersonic flight. For the wings, they chose intermediate modulus carbon fiber epoxy with high modulus fibers for the spar caps and pre-impregnated materials for the leading edges and ribs, powering the baby boom. The XB-1's thrust comes from 3 General Electric J85-15 turbojet engines, each a proven workhorse found in aircraft like the Northrop, F-5 Freedom Fighter, and T-38 Talon. Together, they deliver over 12,000 pounds of thrust, enough to propel the XB-1 to Mach 2.2 with a range of more than 1,200 miles. Boom's long-term plan, however, is to replace these with its own Symphony engine, co-developed with Florida Turbine Technologies, GE Additive, Standard Aero, and other top suppliers. Symphony is projected to generate 35,000 pounds of thrust, operate on 100% sustainable aviation fuel, and cut operating costs by 10%. It's also expected to last 25% longer between overhauls. The engine's design includes highly efficient variable geometry intakes and exhaust to manage airflow at different speeds, minimizing the notorious sonic boom and reducing noise on takeoff and landing. Boom's real goal, the XB-1, is just the appetizer. The main course is Overture, Boom's planned commercial supersonic airliner. Designed to carry 80 passengers, Overture will measure 201 feet long with a 106-foot wingspan and cruise at Mach 1.7, about twice as fast as today's fastest passenger jets. It will feature 4 Symphony engines with a combined thrust of 140,000 pounds. While the Concorde chased Mach 2, Boom has intentionally scaled back to Mach 1.7 to balance performance with efficiency and regulatory constraints, while still having transoceanic travel times. Overture's operational range of about 4,900 miles makes it ideal for routes like Tokyo-Seattle or London-New York. Flying at 60,000 feet, passengers will be able to see the curvature of the Earth, a view previously reserved for astronauts and U-2 spy plane pilots. Breaking the sound barrier. Again, it took Boom several years of design, construction, and testing to get the XB-1 ready for flight. In March 2024, the test program began, with the ultimate goal of exceeding Mach 1. On January 28, 2025, that goal was achieved. Under the control of Boom's chief test pilot, Tristan Japito Brandenburg, the XB-1 climbed to 35,219 feet and accelerated to Mach 1.22, becoming the first independent, privately built aircraft to break the sound barrier. Fittingly, the flight took place in the legendary Bell X-1 Supersonic corridor over California's Mojave Desert, the same patch of sky where Chuck Yeager made history in 1947. The area has also hosted first flights of icons like the SR-71 Blackbird and X-15 rocket plane. What's next? The XB-1 will continue flight testing through late 2025, gathering data to inform Overture's development. Boom aims to roll out the first production Overture in 2026, complete a first flight in 2027, and secure FAA certification by 2029. It's an ambitious schedule, but one that has already attracted serious attention and money. A business model built for the 21st century. Each Overture will cost around $200 million, placing it in the same price league as next-generation military fighters. Unsurprisingly, defense contractors are taking notice. Northrop Grumman has partnered with Boom to explore Overture for rapid delivery of medical supplies, emergency evacuations, and large area surveillance. Meanwhile, since 2020, Boom has been working with the U.S. Air Force on a cargo and personnel transport variant tailored for high-speed logistics. Civil aviation isn't being left out either. American Airlines, United Airlines, and Japan Airlines have collectively placed 130 pre-orders for Overture, showing that despite past setbacks, the appetite for supersonic travel is alive and well. The Overture Super Factory. Building a supersonic fleet isn't just about design, it's about manufacturing at scale. To that end, Boom has opened the Overture Super Factory in Greensboro, North Carolina, where they plan to produce up to 66 airliners per year starting in mid-2027. From there, the company envisions a gradual ramp-up of production and route networks, with the first paying passengers boarding in the early 2030s. Why this time might be different. Past commercial supersonic travel efforts failed due to deafening noise, poor fuel efficiency, and high operating costs. But Boom is tackling these challenges through advances in variable geometry intakes, aerodynamic shaping, and optimized flight profiles to reduce sonic booms. Designing Overture from the outset to run on 100% sustainable aviation fuel to cut life cycle emissions. And leveraging modern materials, efficient engines, and optimized cruise speeds to make ticket prices competitive with business class fares, which, combined with increasing environmental pressure on airlines to decarbonize, makes the economics of high-speed, fuel-efficient travel more compelling. A glimpse of the supersonic future. If Boom's vision becomes reality, the impact could reach far beyond prestige or novelty, ushering in an era where New York to London takes just 3.5 hours, Tokyo to San Francisco is a 6-hour journey, and time zones are far less of an obstacle for global business. For travelers, this isn't merely about saving hours. It's about unlocking new opportunities. Quick transoceanic business meetings become practical, and international day trips once reserved for the ultra-wealthy with private jets could be within reach for a much wider audience. And that's our deep dive into Boom's XB-1 and the future of supersonic travel. If you're as excited as we are about seeing these futuristic jets streak across the skies, hit that like and make sure to subscribe. Thanks for watching, fly fast, and we'll see you in the next video.